Hi guys, hello. My name is Shahar and I have a studio providing UX, UI and product services for startups, mostly on the security fields. Basically, we're helping those startups by making complex products that are unique and easy to use while ensuring that every aspect of the product is aligned with their vision and the user needs. Now, many times in those security products, when alert is raised or an incident starts flagging, there are a lot of details that need to be connected together in order to understand what happened. Most of the time, there is a big story behind every security incident. Generally, it's not wise to just throw a table of alerts at the user and say, here are all the problems you need to solve. Because from each alert here, I need to understand what happened. So I'll go to the asset page, and there I need to find out which assets were affected. And the moment I find the assets that I'm looking for, I need to go and investigate what happened in the event page. So it turns out that just to understand what happened and what the event is, our user need to go and waste a lot of time trying to understand the story and where he need to investigate. Now, we've had a lot of moments in the product team where we felt like we couldn't tell the story as needed when the user jumps from table to table. Ironically, when we started looking at the customer's assets and mapping them out, it was easier for us to explain what was happening there. We could easily show now that there are many issues, but they only affect two assets, and the event is likely somewhere in the communication between them. The map actually helps us to show connection and can highlight issues, but the greatest value of those maps is that they help us to tell a story. Now, I want to talk about a few products, the story we needed to tell in each one of them, and how the choice of the proper mapping tool helped us in telling this story. So the first product I want to discuss is one I worked on almost 4 years ago with a company specializing in cloud security. Back then, these guys were able to integrate with the client entire cloud environment, analyze it, and provide list of recommendations on how to fix and enhance the security over there. Each line here indicates an issue, and they really knew how to provide a comprehensive cyber report, but when we showed to users this list, they were shocked. They didn't even know where to start, which finding is more critical, and which one has the most impact, or which one is easier to resolve. Eventually, we realized that when we present to users this finding as a list, we disconnect them from the context of the cloud environment they know. And each row here for them represents a huge headache without a clear and familiar source. So we use a tool that simulates the customer cloud environment. This is actually how the customer knows his business. He has lots of products, all organized within cloud or different clouds. Above this environment, we presented the finding we discovered. Those are all the red points and lines here. The fact that we started looking at the cloud environment as it's built and represent our finding as an extra layer on top of it helped user understand the context of where the problem is and who it's affecting. Once the user understood and prioritized who among the issues is the most critical for his environment, he could delve deeper and get all the information we found previously, only now he has much deeper context about the problem. In this example, we used hierarchy map, and the story it tells is, here is your environment, you already know it, and here are all the issues we found, but as an additional layer. The map actually helped us to put what we found into context and to pin down for the user what each finding is about. The hierarchy map is the most basic type of mapping, and it can tell us about the asset orientation within a group. But an additional advantage is that this map can present many layers of information upon those assets. So another product that utilizes hierarchy mapping is from a company specializing in deception security, which is a strategy that uses traps, decoys, and fake resources to detect malicious activities, while the goal is to mislead attackers by presenting them fake view. Now, imagine you're the security manager of a very big company, and here you have a table with all of the departments and employees. And deep in your mind, you're really afraid of attackers breaking into those accounts. But you also know it's probably going to happen eventually. So what do? You deploy traps throughout the system. Basically, you scatter many dummy accounts throughout the environment because, first of all, you're really confusing those attackers. Second, you're causing them to waste a lot of time wandering dead-end streets. And third, the moment the attacker starts messing with the trap, you can see his movement. Now, imagine seeing all this on one screen. I want to see my assets. I also want to see the traps. And I also want to see the progress of the attacker within the organization. Now, jumping from table to table isn't really the solution, and you can't manage event tracking like that. So first of all, we gave them a view of the entire organization. Here are all the departments and the employees. Below, we added a button that adds to the view a layer of all the traps we placed there. The moment the system detects that someone started messing with one of the traps, it simply frees the situation and marks his entry path. So the hierarchy map can provide us with a lot of information, and it's suitable for situations where we want to aggregate in one view data from different sources. Now, let's discuss another type of map. So with SafeFlow, the map told a completely different story. SafeFlow is a system that monitors charging stations of electric vehicles. And in systems that monitor products, it's important to have quick and clear identification of the problem. Not what might happen, but what has already happened. Now, if I'm looking at their dashboard, I see that I have two high severity alerts. There is an unfamiliar asset that just appeared in the system and another asset that stopped communicating. So how is the regular flow supposed to work? As a security persona, I'm supposed to go to each alert and start to investigate what happened. I need to go and investigate who was affected by each alert and which event led to the alert being triggered. And from there, I'll delve deeper into what happened. And by the time I finish investigating, the entire site will go on fire. This process took too much time, and we needed to find a way to tell this story much faster. So at the beginning, when we started thinking about mapping the assets, we asked ourselves, what type of map do we need? It was clear to us that showing all the sites on a map would be very valuable, but on the other hand, it didn't make sense to map out every charging station and every asset within each site according to physical location. Showing each asset location was just not interesting enough. And while within each site, the network and the communication pattern between the asset could tell much richer story. So if we said before we're dealing with a monitoring system, then we wanted a map that would mark every asset that deviates from the communication rule defined for it, or from what the system recognized. We wanted a map that could show us the relationship and the communication between the assets. In order to tell the story, we provide them with a map of all of the sites in the middle of the dashboard. The user can tap any of the sites, get some high-level information, and a mapping of its entire site. In this map, the story is about how the network communicates within itself or where the status has changed. Here, the connection and the relationships between the assets are more interesting than their physical location. Now, I want to show you why this map holds so much value and focus on this specific case. We have an unfamiliar asset that just appeared and another asset that stopped responding. According to this map, the user immediately sees that there is an issue with the power supply. You see that the controller that monitoring the electricity has stopped responding, hence the first alert about the unresponding asset. And as a safety mechanism, the generator starts supplying power, and here is the alert about the new asset. Overall, such an event is not a catastrophe, and our user need to contact someone to check what happened to the electricity. But on the other hand, those two alerts could present a completely different scenario where the user sees that there is a foreign asset in the system, and the system can't even identify its type, and it's already in communicating with one of the chargers. And that's already a very serious event that requires intervention. So this map quickly tells the story of what happened, and instead of wasting time trying to understand the event and what happened, our user already exploring ways responding to it. So we talked about maps that tell us about the hierarchy and how the organization is built. And we also talked about maps that can tell us about the network and how the communication is managed. There are other type of maps that can tell us a different story, maps that can explain to us the logic of the system and how it's think. So the next example is for a product that secure factories. And the thing that distinguishes those factories is high automation and internet connectivity, what many refers as Industry 4.0. So here too, we knew how to scan and analyze the entire factory and identify all the machinery, tools, and production lines, and then monitor all the activity within the factory. So we had a page for assets, which display all the endpoints in the production lines, and page for policies with rules, what each machine allowed and not allowed to do, and page for alerts, and page for vulnerabilities, and many more. But all these pages always operated separately, and it was difficult to us to show how all the features work and interact together. So we present everything on a map, and at first we display all the assets on a hierarchy map according to the hierarchy of the factory itself. It helps us better understand each asset, where it's located physically in the factory and whether it has issues, but there were quite a few more systematic issues that required us to explain to whom each asset is connected, who manages it, and especially what rules apply to it. We realized that the map we chose was not suitable because the map could only display severity and location, but it couldn't explain why each asset behaves the way it does. So we changed the requirements and created a different map. We created a map that highlights the rules that organize the assets within the network, what they are allowed to do, and with whom they are allowed to communicate. Essentially, we formed groups of rules or security zones, as we call them, and within those groups, we placed the assets. Now we could show much faster whether the problem lies with the assets itself or with the entire network, the source of the problem, and why the alert has triggered in the first place. Now we could show that despite the assets being with a group with very high security level, it still has communication with a group of assets from another source, which is a very significant problem. Actually, here we are no longer dealing with a physical map or a network map. The story here is how the assets are organized into groups according to certain rules. This map is more logical, and it explains how the system operates and how the assets are organized within it. So far, we discussed 3 types of maps, and in the next project, I learned that several maps can coexist within the same product. So the next project is for a company that provides cybersecurity for trains. And from the beginning, there was always the question, what is the best way to present the assets? There are so many personas, and each one looks at the train differently. Placing randomly all the assets in space and show the connection between them suited only small part of the users. But in this product, it was clear to us that we need to start looking at the train through the user's perspective and provide them with the same viewing experience they are familiar with. So we ask each persona, how do you see the train? After quite a few questionnaires, we decided to place the next dropdown right above the map. We had a basic display of all the assets scattered randomly. And to this display, we provide sort of different views. We call them glasses. So the operation team told us that they view the network as a system of access points controlled from above. They need to see which are the endpoints and who controls them. They weren't concerned about the rules governing each assets or where they are located. They wanted to see who is giving instruction to whom. The security personnel responsible for monitoring the network told us that they need to see the network as different security zones, and within each zone, there are the assets. For these guys, it was most convenient to view the assets as groups of security rules. The monitoring personnel who decide who travels where told us that they need to see the assets as groups moving along the tracks, because for them, physical location is critical. They need to see that there is no other group which represent another train in the same segment. Here I understood that different maps can coexist within the same product, and in all of them, we can see the same assets. They haven't changed, but each user sees them entirely differently according to his role, hence the glasses. Now, let's talk for a moment how users work with these maps. Eventually, as a user, I need to address problem and prioritize. How do I know what is more important, or who should I approach first? As the one building those maps, we need to decide how do we capture the user's attention and how do we signal a problem to them. So it's possible to show all the different types of the assets on the map. And it's better to show if they have problems or issues. And we can show if there are several problems and their types. And then someone will want to see the names and addresses of those assets. And eventually there is a lot of noise on those maps. The user dive in and out. The distribution is never optimal, and there's always a lot of clutter on the screen. Our job is to try to reduce as much of the noise as possible and help the user prioritize. But if we return for a moment for the story we are trying to convey with the map, then the map should indicate where there is a failure, where something is not working properly, or where there is a deviation from predefined boundaries. It's not supposed to show all the information in the system, and therefore it's better if the map will help the user only with the initial prioritization, and only afterwards, after the user has already selected the asset, we should add the rest of the information in some modal that provides more info about the problem. To conclude, I want to present a little bit different project. At Robosoft, we've built a very unique map, and I call it Theater Map, and you'll understand why in a moment. Their product is a part of the Security Operations Center, which is commonly known as SOX, and the product is essentially a bot that investigates cyber event instead of human analysts. It shifts through mountains of data and decides, gods know how, to connect strange behavior it finds to cyber event and say, I think what I find here is an attack. It knew how to find and locate the attack. It could pinpoint the attacker, the victim, describe the process, and even provide some quick solution to mitigate the damage. But at the end of each session with the client, we found ourselves needing to explain again and again how the bot arrived at the conclusion that there was an attack here. The bot could provide very detailed finding, but it couldn't explain how it connected them, leaving customer with a lot of questions in the end. Until in one of the conversations, the word movie was mentioned, and the investigator asked us to connect all the events into a timeline. He wanted to understand for himself what happened. That's when I realized that the attack was not the story. He wanted to see how we connected all the events and how the bot arrived at the conclusion it did. He was less interested in what happened or to whom it happened. In this part, he relied on us. He wanted to see that the connection we made were accurate. So we connected all the bots finding and placed them on a timeline and added a player below. We showed who was involved and when there were unusual events, but mainly we highlight the connections between the events and the suspicious behavior the bot found. Those are the yellow points, and those are the same questions that remain with our users. So here we have a map. It's not logical or network or hierarchy, but it certainly succeeds in telling the story, showing that the bot made logical connection to declare it's an event. Here is essentially I learned always to ask, what story do I want the map to tell? In this case, the map doesn't actually describe the attack itself, but rather the way the bot connected the events to truly justify that the events require attention. I just want to conclude that the decision to view the product as a map doesn't stem from a UI solution, but as a way to tell a story of how the product integrates with the user needs. Drawing assets on a map instead of a table is not a big challenge. The interesting part is to understand what kind of map the user needs and how to align it with the system value. Thank you very much.